Welcome back to another week of online geometry. Good morning, good afternoon, good evening, whatever time of the day it is. I hope you are enjoying yourself. Hope you're being safe, having fun. Um, as you do this, I would like to send out a thank you to everybody who has been participating and submitting their assignments and their quizzes in a weekly basis. The turnout for all the geometry classes has been great. I would say in mine alone, it's over 95% of you are completing and submitting almost everything every single week. So thank you for that. Let's keep up the good work here as we move forward. Before we start to talk about today's lessons, just a couple things to go over. Remember, everything can be found in Schoology. Okay. If you scroll down, here we've got, you see me highlight here on my screen, week 4. You can click on the link to get to the Google Docs. If you have access to problems with Schoology, you can just go off the Google Doc. You'll need to come to Schoology to submit your answers, but you can get the links from there. Remember, if you have the capability, you can print your blank notes. We're going to look at task number 1 today. If you click on it, there's a copy of the blank notes you can print out. Again, if you do not have access to a printer or you don't want to, you don't have to print it out. Just get a blank sheet of paper, notebook piece of paper, and you can jot down the problems and draw a sketch of it as we go through these. Okay, you can do that without having to print them off. Right here will be the link to the video, which isn't there because I'm making it right now. One thing I want to point out is I started adding it last week. At the bottom are some directions and shortcuts. So if I pull up the video from last week, day 1, I'm going to pause the video, but down below where it's got Mark Natsky, video details, if you click on show more, it's going to bring up some details to it. By clicking on the times you see on the left, it will skip you to different aspects in the video. And you can see those, so it takes you right there. So you can skip between the video if you have a particular part or section that you want to come back and watch, or if you come on in to do that. So that is an option that's available for you. This is from last week. There's a flow chart. Steps to solving trig equations for using SOHCAHTOA. This week we added a different flow chart. You'll see it's called solving a triangle for missing sides or angles. This will help us to determine what method we need to use to do that. And we'll talk about that here in a little bit as we get to that and how we go from there. There's also a link to the completed notes. So you can do them on your own. Click on that and just look at the notes. That's the option there for you. There's the blank homework, independent practice that you can print out, then you'll submit in Schoology. I will talk a little bit about that later on when I get to the Schoology or the assignment. Did add a little bit where we're going to have you show a little work to it. So I would recommend, if you don't watch the entire video, at least you come back and check out the independent practice detailed information at the end. A couple things just to hit on before we get started. Remember to stop in, see your geometry teachers during their office hours and Google Hangout. If you can't make a Google Hangout and you have an issue, email your teacher. Get in touch with them so that they can email them and maybe work out a time with them to set up and stop in and see them maybe during a different time. But the only way we can help you is if you reach out to us and you contact us. So please do that. Grading scale. It is in Schoology. It's also in the Google Doc here. But if you go to Schoology, you'll see here we did finalize it. So your breakdown for your grade is 60% of it comes from the in-class learning, 40% of your semester grade will be from the remote online learning. That breakdown, 30% of that is going to be your summative assessments, which is our quizzes/test. 10% is your formative assessments, which is the independent practice that you submit each week. Each independent practice will be worth 4 points, similar to it's been all year. If you get an accuracy score greater than or equal to 50%, you will earn a 4. If you get anything less than that, you're going to need to contact your teacher to talk to them about the options to earn a 4 for that assignment. Otherwise, it'll be a 2. If you don't submit it, it will count as missing and be counted as a 0. So some options could include going to Google Hangout office hours, talking about what your mistakes are, submitting corrected mistakes, showing corrections, doing something like that. The big thing that I want to stress, in order to earn a grade of passing for the class, a student must have a grade of 60% for both their overall semester learning and the remote learning. So even if you had a high enough percentage in the on-class, you still need to earn at least a 60% during the remote learning process to earn a passing grade. While 60% is all that's required, we do expect each student to continue to strive to do their best. Do remember that the stuff that we're talking about right now is skills that we'll build on for the future. And you'll use in advanced algebra, FST, pre-calculus, especially this trigonometry. This stuff you will see every year in every math class from this point on. So, and every year you build up more and more and more on it. So we're starting with the basics to it, but do that. And it also will show how good of a student you are by how much you complete and how much you do. If you show that you're not satisfied with just getting the 60%, that's going to show a lot about your character, and we strive and want you to do your best in everything that you do. Calculator, make sure your calculator mode is set to degrees and not radians. We've had some people submit the quiz and assignments that based on their answers, and when we check them, we can tell you're in radians and not degrees. Just a quick note on that. For example, if I type in sine of 75, I get negative 0.3877. That's not right. Okay? The problem there is my calculator is in radians. So you have to go to the mode. It's right next to the second key. So I click on mode. Notice radians. I've got the mouse circling here where degrees is. You need to go down and select degrees and highlight degrees. Once I've done that, I can quit out of this screen. Now if I type in sine of 75 again, I get 0.9659, which is correct. So notice if you're in degrees or radians, there's a difference as to what it is. And the difference in degrees and radians is kind of think of it as centimeters and inches. They both are forms for measuring angle measures, but they're different units. We're not going to look at radians at all in geometry. That's how in advanced algebra you build on that. You'll talk about radians and radiant measures to build on this. So make sure in that. And also when you're typing in, make sure you don't round. So if I type in sine of 75 and I want to multiply this answer by 8, I'm going to hit answer times 8. I get 7.727. If I just do, say, 0.96 times 8, which is sine of 75 rounded 2 decimals, I don't get the same answer. Notice my two answers are different. So if you're rounding before you get to your final answer, you're going to be incorrect. So some of you are getting your answers wrong in Schoology because you're doing that. Any questions? Stop in Google office hours, talk to your teacher. So let's get started a little bit today on what we're looking at. So we're going to look at trigonometry with all triangles. Again, homework from last week, stop in. Particular today, we're going to talk about what's called the law of sines. Before we get there, in Module 13, the last 3 weeks, everything we focused on involved missing parts of right triangles. We used the Pythagorean theorem or SOHCAHTOA. That's the deal, key. Okay, everything we dealt with in the last module had a right angle in it. It was a right triangle. Well, what if it's not a right triangle? What if I have a triangle here that is not a right triangle? What am I going to do there? That is what we're going to focus on today. That's what we're going to look at. What can I do? What are my options? So our warm-up says find the measure of side B. Well, can I use SOHCAHTOA? Remember, in order to use SOHCAHTOA, it's got to be a right triangle. If I take 180 minus 53 minus 29, angle A has a measure of 98 degrees. So I don't have a right triangle. I cannot use SOHCAHTOA. That's all I know. Well, let's do this. What if I draw in a line from A down to BC and make it perpendicular? If I draw in the altitude, we talked about this back in Module 8, special segments and triangles. An altitude is a segment that's perpendicular to one side and goes to the opposite vertex. It's also the height of the triangle. Well, notice I just divided this triangle into two right triangles. Well, I want to find B. Well, on the right, I could use 29 as my reference angle. B would be the hypotenuse. I could use the measure of H as my opposite side. Well, I can use the triangle on the left to find H. So let's look at the triangle on the left, triangle ABD here. Remember, let's ask ourselves these questions. What's the reference angle? 53 degrees, correct? Which side do I want to find? I want to find H. And which side is that? That is the leg that is opposite of 53. So that's my opposite side. The side that I know is the 4.9. And that's the hypotenuse. Which trig function uses opposite and hypotenuse? Sine does. So this is back to what we talked about. So let's use this. Sine of the angle, sine of 53 equals the ratio of opposite over hypotenuse. The opposite side being H and the hypotenuse being 4.9. Well, let's solve for H. How do I clear fractions? Multiply both sides by 4.9. They'll cancel out on the right side. Leaves me with just H equals 4.9 times sine of 53. Now I could find that number as a decimal, but I'm going to have to use that over my other triangle. So I'm not going to, because if I did that, what I'd be doing is I'd be rounding. Remember, I do not want to round until I get to the end. So let's look at triangle ACD, the triangle on the right here. Let's ask ourselves those important questions again. What's the reference angle? Now it's 29 degrees. Which side do I want to know the measure of? I want to know B, which is the hypotenuse. The side that I know the measure of is 4.9 times sine of 53, which is H. Because remember, H equals that. And which side is that? It's the opposite side. Sorry, I noticed as my quickens I had some typos here. So, typing them in on adjusting on the fly. Which trig function uses opposite and hypotenuse? Sine does. So let's set up our equation. Sine of the reference angle, sine of 29 equals the ratio of opposite, which is H, but we said that H equals what? 4.9 times sine of 53 over what? B. Well, let's solve this. Let's clear fractions by multiplying both sides by B. They'll cancel out on the right. I have B times sine of 29 equals 4.9 times sine of 53. How do I solve for b and get b by itself? Well, I got to get rid of the sine of 29. So how do I do it? I'm going to divide by it. If I divide the left side by sine of 29, they will cancel out. Leaves me with just b equals 4.9 times sine of 53 divided by sine of 29, which ends up equaling 8.071. How do we get that? Well, let's take a look at my calculator. I have 4.9 times sine of 53. One of the keys here is you have to make sure you close the parentheses, okay? So if I'm typing in sine of 53, I have to close the parentheses. Okay, 4.9 times sine of 53. That is going to then be divided by sine of 29. There's how I get 8.071. Which, rounded to the nearest hundredth, 2 decimal places, is 8.07 is my answer. Do I want to do this every single time? Draw on the hypotenuse, or draw on the altitude, create 2 right triangles, and do that. Is it an option? Yes. But do I need to? No. The question is, can we come up with a shortcut? So if I look at what I did here, this was some work. So notice the triangle on the left, I did sine of 53 equals h over 4.9. I solved for h, correct? Well, let's just say on the triangle on the right, instead of putting it in, sine of 29 equals opposite h over b. Well, if I solve that for h, notice I have 2 equations here that both equal h, which means if they both equal the same height, aren't they equal to each other? Yeah. And I can solve for b by dividing by sine of 29. That gives me my answer of 8.07. Now, I want you to take a look at this number 5 here, because this is where we're going to get to. What I want to do is take both sides and divide both sides by 4.9. They'll cancel out on the left. I have 4.9 on the right. I'm going to divide both sides by b. They cancel on the right. So what that gives me is sine of 53 over b equals sine of 29 over 4.9. Notice here I have 2 ratios. I've got 2 ratios. Well, this is an example of what is called law of sines. Here's another example, but instead of giving numbers, they give everything in terms of a's, b's, and h's. And there they got sine of a over a, which equals sine of b over b. That's taking number 5. I'm dividing both sides by a and both sides by b, and they cancel out there. The other option to do with number 5, the other option I can do with number 5 here is to take both sides and divide it by sine of a. They'll cancel out on the left. Take both sides and divide by sine of b. They'll cancel on the right. I have b over sine of b equals a over sine of b. That right there is my example of law of sines. Notice what I have, and I only showed it to you with 2, but really what law of sines is it is 3 ratios that are equal to each other. And what we're going to do is set up a proportion. And we're going to use 2 of these ratios. Any 2 we want. And we're going to set them equal to each other. We can use this to find missing sides or angles. Now, in order to do this, one of the keys that we need to have is called what's an opposite pair. In order to use the law of sines, I need an opposite angle and an opposite side that I can use to measure for. So remember back to when we talked about ratios, we can write and we can flip and take the reciprocals when solving proportions, as long as we do it to every single term. So that's why there are two different ratios. The top one gives me sine of the angles. The bottom gives me the three sides. Notice side A is opposite of angle A. Side B is opposite of angle B, and side C is opposite of angle C. The other option is put the sides on top and sine of the angles on the bottom. Well, the reason we give you two is because there is a reason for this. Today we're going to look at solving using law of sines to solve for sides. That means we're going to use the bottom one. We want to put the missing measure on top. Reason being is I want the variables to be on the top. I'm going to use the top one in our next lesson when we look for solving for an angle. And I talked about the flowchart. So the flowchart here, we've got to ask ourselves one question. Is it a right triangle? If the answer is yes, we talked about using Pythagorean theorem or SOHCAHTOA. That's what we've talked about so far this year. There is another option called special right triangles. We did not talk about that in class, and we're not going to cover it this year, but that is another option as well. Well, if it's not a right triangle, the one question we have to ask ourselves is there an opposite angle side pair? If the answer is yes, we're going to use our law of sines. If the answer is no, well, that's law of cosines. And we're going to talk about that next week. So let's jump in example number 1. This problem should look familiar. This is the exact same problem from the warm-up. So we do know the answer is 8.07. But can I get there using law of sines? Well, it's not a right triangle. The question I want is, do I have an opposite pair? Okay, well, let's look at it. I need an opposite pair involving this side that I want to find. So if I want to find side B, my opposite pair is angle B, which is 53 degrees. That's one opposite pair right there. I need another opposite pair. Well, the other opposite pair has to involve two measures that I know. Well, notice I notice angle C is 29, and I know the side opposite of angle C is 4.9. There's another opposite pair. So right now I've got two opposite pairs. So I can use law of sines. Law of sines is ratios. And I'm going to use the one that involves the sides on top. I'm going to take a side. And I'm always going to start out with the side I want to find the measure of. So I'm going to write a ratio where it's what? B. B over what? It's going to be the side measure over sine of the angle opposite of it. So it'll be B over sine of 53. Because I have one variable, my other ratio cannot have a variable. That's why I'm using this other opposite pair, which involves 4.9 and 29 degrees. I'm going to put the side on top. Because if the side's on top in the left ratio, the side has to be on the top on the right. So I'm going to put 4.9 in the top. And that is going to be over sine of the angle. And the angle measures 29 degrees. I'm going to solve for B, like we've been doing all year. Clear fractions. Well, that means I got to get rid of sine of 53 from the left side. So I'm going to multiply both sides by sine of 53. They'll cancel on the left. I'm left with B. B equals what? 4.9 divided by sine of 29 times sine of 53, which is very similar to what we typed in before, but they're in a little different order. Do you think it's going to matter? Let's try this. Let's go 4.9 divided by sine of 29, close the parentheses on it, times sine of 53. I get the same answer, 8.071. Now notice here on this problem, before I go back, I typed in exactly. I did not round anything. I want to show you something. If I do sine of 29 and sine of 53 is decimals. Okay? 0.4848 and 0.7986. Well, what if I take 4.9 and instead of dividing by sine of 29, I divide by 0.484? That's 3 decimals. It's ain't too horribly off, is it? And then I multiply that by sine of 53, which is 0.798. I get 8.078, which actually would tell me to round up to 8.08. They're pretty close. Okay? But am I 100% accurate? No. So some of you were getting close, but not getting it correct because you were using rounded numbers before you get to the end. So always type in using the sign feature. Don't do it. By doing it step by step, it required me to type it in more into my calculator. So it's 8.071, which rounds to be 8.07. Example number 2. I need opposite pairs, not a right triangle. Because if I do measures here, angle A is 58 degrees. So nope, angle A is not a right angle. I don't have a right triangle. Well, I need an opposite pair. I want to find side A. So therefore, one of my opposite pairs has to involve side A and the angle A. Well, I told you it's 58. How did I get that? Well, the 3 angles of a triangle have to add up to 180 degrees. 180 minus 42 minus 80, angle A is 58 degrees. So there's one opposite pair. I need another opposite pair that involves 2 measures. I know the measures of both. I know the measure of angle B, but do I know the side across from B? No, can't use it. Let's try C. I know angle C. Do I know the side across from C? Yeah, I do. 15 and 80 are the side and angle that are opposite of each other and involve C. So when I do sines, I'm going to write my ratio. Put the variable of the variable I want to solve, which is side A. So I'm going to put that on top. A over what? Well, that's a side, so it's going to be A over sine of the angle that is opposite of side A, which is 58 degrees. My other ratio then is going to involve my other opposite pair. A was a side measure, which means in my second ratio, the top has to be a side measure as well, so it's going to be 15. 15 over sine of what angle is opposite of 15? Sine of 80. So notice in my proportion here, the top 2 numbers represent side lengths. The bottom 2 measures represent sine of the angles. The fraction on the left is one opposite pair. The ratio on the right is the other opposite pair. Well, now I got to solve it. I want to get A by itself. That means I got to get rid of sine of 58. Well, to do that, I'm going to multiply both sides by sine of 58. They will cancel out on the right, or on the left side, which means I'm only left with A. A equals what? 15 divided by sine of 80 times sine of 58. Let's type that into my calculator. $15 divided by sine of 80. Make sure you close the parentheses after the 80, because I'm going to type something after. If I don't close parentheses, it'll take sine of whatever's inside of that parentheses. Divided by sine of 80 times sine of 58. Because this is at the end, I couldn't get by without closing that parenthesis. I'm going to close it anyway, just to have it. And then with 12.916 with 3 decimals. If I want to round that to 2, looking at the third number, which is a 6, tells me to round up to make it 12.92 being my answer. Example number 3 is an application type of problem involving law of sines. Suppose 2 park rangers because it's an application of when can we use law of sines to find anything. So two park rangers are in towers. They're 10 miles apart. One's in tower A, one's in tower B. And they spot a fire off in the distance. That is represented here by point C. That's my fire. Well, they're able to calculate the angle measures. The angle measure created by the line of sight to the fire and the opposite tower. So angle A is 135 degrees. The angle of tower B here is 14 degrees. Can we use law of sines to find the distance of the fire from tower A? So I want to find B here. I'm going to call it B because it's the side that's opposite of angle B. That's what I want to find. It's not a right triangle. Can I use law of sines? I've got to have opposite pairs. Well, notice side B and angle 14. The angle 14 will give me an opposite pair. That's one. I need another one. Can I use 135? No, because I don't know the side across from that. Well, can I use 10 in angle C? The question is, can I find the measure of angle C? Yes, you can. Remember, three angles of a triangle add up to 180 degrees. So if I do 180 minus 35 minus 15, that ends up being 31 degrees. That means angle C here is 31 degrees. So do I have an opposite pair here? Yes, I do. So I've got one opposite pair involving the side I want to find the measure of. I have one opposite pair involving two sides and an angle that I know the measure of. So let's write my ratio. B. I always put the side I want to find first in the top left. In this case, I'm finding B. So I'm putting B there. B over what? Sine of what's the angle across from B? 14. Equals the ratio. Sides on top. My other opposite pair is 10 and 31. I'm going to put 10 on top. Over sine of 31. The one thing I want to stress, and the biggest common error I've seen over the years in kids when they do this in law of sines, is do note when you do the angles, it's sine of the angle measure. It's sine of 14, sine of 31. Kids always, every year, kids do it. They just put over 14, over 31. Okay? It's over the sine of the angles. Can I solve for B? Let's clear fractions. How do I do it? I got to get rid of sine of 14, which is the denominator of the left. So I'm going to multiply both sides by that. Multiply the left side by sine of 14. They cancel out, leaves me with just B. The right side, this is the number. I'm just going to type it into my calculator. And I'm going to do it at once. Again, I'll show you. 10 divided by sine of 31 degrees, close the parentheses, times sine of 14 equals 4.697, which rounds to be 4. Third decimal 7 tells me to round up. Rounds to be 4.7 miles. I will show you another option for typing this into your calculator. So for example, if I just want to find the right side, if I do 10 divided by sine of 31, what I do know is the right side equals 19.41. Well, I can multiply that by sine of 41. Use the answer features. If I just hit times, it will automatically take the previous answer, which is what I want, 10 divided by sine of 31. And I'm going to multiply that by sine of 14. And again, it still gives me the same answer. Questions? So really, in this lesson this week, we're focusing on one thing. Using the law of sines to find angles. That's all we've got. Your homework assignment is the week 4 test number 1. It's the law of sines sides worksheet. Okay? As you do it, each picture should have a drawing with labels. Well, in this homework assignment, there are pictures for each and every single problem, so you don't have to worry about that. You want to write an equation and show your algebra and how you solve it. Make sure you write with units of measure, and then round all answers to the nearest hundredths. And make sure you submit your answers on Schoology week 4. This is task number 1, the law of sides independent practice. So if I go back, if we go to Schoology, because I want to show you how to enter this in Schoology. Week 5, Unit 5, Schoology Independent, there's where everything is. As I make the video, it's not open yet to you, but right here it is, week 4, task 1. Okay, here's the blank worksheet, which gives you the problems. Print it out, or you can do it without just by looking at it, doesn't matter. But here's the Schoology. Remember, you're submitting that. Now I want to show you something. So here's a preview. Okay, you're going to use the law of signs to find the following measures. Round all answers to the nearest hundredth, 2 decimal places. For each number you got to do in your sheet, there's going to be one question. It's going to ask you to complete the equation of your setup. And I'm going to show you how to do that. Then the second question, part of it will ask you for the actual measure. So if I start this right here, right now, using only the terms in the word bank provided, complete the equation you would need to solve for side B. So I'm actually going to do number 1 for you. Notice we give you a word bank. There's a list of words. Your answer, these 3 blanks, are going to be filled with one of these letters. Okay? Well, if I click what I want B. Side B is going to go over what? Over the angle. Which angle is opposite of side B? 14. So if I click the blank that involves that, which is blank 2 involves the denominator below B, well, which one is it? It's going to be sine of what? 14. Now what I can do is I can just click on this. I can just click on sine of 14 and it'll fill it in for me. Okay? The ratio on the right, I want the top. What's the top going to look like? Well, my other opposite pair is the 15 and 150. I'm putting the side on top, so I can click on 15. Now you can type it in if you want. So in blank 3, it's going to be over what? Sine of what? What angle? 150. You can click on it. Now notice the other option, you can type them in if you would like to, but you need to type it in with no space between the N and the number. If you put a space in there, Schoology is gonna mark it wrong. Okay? Otherwise, you can get to it by just clicking on it. So if I look at number 2, like I said, click in the blank, it's highlighted. All you gotta do is click on what you want it to be. Okay? What you want it to be. I want the 2 sides on top, so A and 10. Well, what's A gonna be over? Is it sine of 45, sine of 80, or sine of 55? Click on it, and it'll fill the blanks in for you. So there's a word bank. All you do is click it, and we'll submit it in. Now, to wrap this up, I have created an extension problem for you. It says use the law of sines to solve for triangle ABC. Now, this extension is optional if you want to. It's kind of a little bit things we've done in the past, but as we've kind of, with the online learning, cut some things down. It's one of the things we've cut down on. What does it mean to solve a triangle? I want to solve for all missing sides and angles. Well, the first thing here, and the first one easiest here, is to do what? I want to find angle C. All missing measures, I'm missing angle C, 31 degrees, because the 3 angles add up to 180 degrees. Well, then I got to come up with some opposite pairs. Let's find side B first. So my 1 ratio is going to be what? B over sine of what angle? Sine of 110. My other ratio then has to involve one or the other opposite pairs. Can I use C in sine of 31? No. Why can't I use that? Because that'd give me two variables. Instead, I want to use the opposite pair that involves what? 8 and sine of 26. Multiply both sides by sine of 110. 8 divided by sine of 26 times sine of 110 is 17.36. Now I do want to solve for C, so let's write a ratio that involves C. C over sine of 44 equals. Now, when I do my other ratio, I could use, because I now know what B is, I could use B in sine of 110. However, this 17.36 is a rounded number, and do not use a rounded number unless you absolutely have to. So I'm still going to use what? 8 and sine of 26. Multiply both sides by sine of 44, and I get 12.68. So that's an extension where they're asking you to find multiple missing sides. Not something you're required to do in the homework, but that is a little bit above and beyond what we were talking about. Remember, if you have any questions, please stop in during Google Hangouts. We look forward to seeing you. Hope you enjoyed this lesson. Hope you had fun. Be safe. Stop in and see us so we can see your face and you can talk back instead of myself talking to myself for 40 minutes to explain this all to you. Thank you, enjoy, and have fun.